Go. Reactions in Chemistry by Tyler the Bold, who got a 45, and Nate the Great, who got a 59. Physical changes. A physical change is when something changes its appearance, but its chemical makeup stays the same. Some signs that something went through a physical change would be a change in color, size, or temperature, or the state of matter. Some examples of this could be a plate breaking, cutting a piece of paper in half, breaking the glass in your phone, or even an evolving Charizard. Chemical change. A chemical change is when something's chemical makeup changes because of a reaction. Some signs that something went through a chemical change would be a change in color, size, temperature, or the object producing bubbles or an odor. The parts of a chemical reaction. There are really only two parts of a chemical reaction: the reactants and the products. What? I was going to read it. I also just realized that says reactants. Substances that undergo change in the reaction. Products. Substances that are produced from the reaction. The law of conservation of mass. The law of conservation of mass pretty much just states that the matter cannot be created nor destroyed at any time, no matter what. So this is why we have to balance equations. We cannot have a certain amount of reactants and then have more or less products formed from the action, because that would be breaking the law. And as this police officer from The Simpsons says, when you break the law, you gotta go to jail. Balancing equations and tips. Step number 1. Count the number of atoms of each element on both sides of the arrow. If they are the same, the equation is balanced. Number 2, if they are not the same, the equation is not balanced, which means that you have to go and save the day. Number 3, you must change the coefficients of the reactants and products until there are the same number of atoms on both sides of the arrow. There is no method except for trial and error. Number 4, double check your work by recounting the atoms of the reactants and of the products, using the new coefficients you have found.
Okay, so types of equations. There are synthesis reactions, decomposition reactions, combustion reactions, and single and double replacement reactions. So this is an example of a synthesis reaction. A synthesis reaction is very simple. It's one thing plus another thing to make one thing. As you see here, we have sodium plus chlorine to make sodium chloride. But the thing is, this equation needs to be balanced, like we talked about. So first, you put a 2 in front of the sodium chloride, and it's still not balanced yet, so we put another 2 right there. So next, we were talking about decomposition, which is also very simple. One thing becomes two things. So as you see here, we have hydrogen peroxide becoming water and oxygen, but also is not balanced yet. So first we put a 2 in front of the hydrogen peroxide, and still is not balanced. So we gotta put a 2 in front of the water. Let's keep moving. So next we have combustion. So pretty much combustion is when you have oxygen on your reactant side and end up with carbon dioxide and water on the other side. But this is also not balanced yet. So we have to put a 2 in front of the oxygen over here, and then a 2 in front of the water over there. Yeah, so that is a combustion reaction. Single and double replacement reactions. So pretty much a single replacement is, as you can see here, we have the A and the B swap place over here for where they be. You know what I mean? Who? You. Okay, now for a double replacement, you have two things swap position. So if you can tell, we have the Ag and the Cl swap, and then we have the Na and the N swap. So if you look at the products, they all flip-flop, swaps, if you know what I mean. So let's look at our example problems. we have these things, our equation, but it's not fully balanced. So we gotta balance it, man. But well, first, if you see here, this is a single replacement, and the zinc and the hydrogen swap places, because now over here, the zinc is with the chlorine. And they swapped places. So, but the thing is, now that they swapped places, they're not balanced. So first, we gotta put a 2 in front of the HCl, and then we also have to now move on to the next problem, because that's balanced. And then this one, I've already accidentally started balancing this one, but if you see here, we have KL and PB swap, or sorry, not KL, that's KI. Nate doesn't know how to read. K and PB swap places, and then NO swaps places with I. So now they're all together, a big happy family, and we still have to put another number to balance it, and look, we now have a perfectly balanced equation. Woo, man!